All right, example 4. Suppose that a sample of n people showed that the average time to complete a task was 13.2 minutes with a standard deviation of 2.6 minutes. Okay, here, if we're trying to identify values, here is x bar, this is the average of a sample, and in the same sentence we're also talking about the standard deviation of course, that sample. So this is not sigma, this is the standard deviation of a sample, this is S. Okay, this is the sample standard deviation. We would like to produce a 95% confidence interval for the true average. The true average, of course, is called mu, and here part A is asking us to do this if the sample size is 25, and then, of course, if there are any assumptions required. Okay, we don't have sigma, okay, we have S instead of sigma, therefore we should be using the t distribution. Okay, the only way that we can get away from using the t distribution if we have S and not sigma is that n needs to be really large. In this case, 25 is not that large, so we are trapped into using the t distribution. Okay, so what we're doing here is we've got the t distribution. Of course, the t distribution looks a lot like the normal distribution. It is a bell shape. In the middle here, we want a 95%, meaning that we have 5% left over to share in both tails. Split it up equally. Got 2.5% in the lower tail and 2.5% in the upper tail. This is a t distribution. Okay, part of the problem with t distributions is they have degrees of freedom, but we know that the degrees of freedom for the t distribution is n minus 1. Okay, n here is 25, so we can minus 1 and we get the value 24. Okay, so if we're trying to look for these t values, these two t n values, what we need to do is go to our t table. Okay, and the t table works a little differently than the z table. You first find your degrees of freedom in the row columns. Okay, our degrees of freedom here are 24, and then we need to find the tail probability of 0.025. Okay, and we'll do this to find what our t value is. Okay, so what you should find from your t value is the value 2.064. Okay, so that's the value here. That's the positive value, 2.064. Therefore, this negative value is symmetric. It is going to be negative 2.064. Okay, so here are my t alpha over 2 values. That's fine. Let me show you where it actually comes from the actual t table. Okay, so here is the t table. What you need to do is find your degrees of freedom first. Here it is, 24, and we want to find where that matches up with the tail probability here of 0.025. So down this column, and here is the value that I found, 2.064. Okay, we've got our t value now. Let's remind ourselves of the formula for the confidence interval. Again, it's x bar plus or minus. In this case, we're using a t value, not a z value, so it's t alpha over 2, and we multiply by s and divide by root n. Okay, so here our x bar value was 13.2, plus or minus our t value here that we just found from our table, which is 2.064, multiplied by s, which we were told here was 2.6, and divide by root n, which we know to be 25. Okay, we can get both of our values, both the negative and the positive values, by using our calculator and finding the value 12.127, and the larger value to be 14.273. Let me just remind you quickly how to do this in Minitab. Okay, in Minitab, we can go to Stat, basic statistics, and one sample t. Okay, we're using a t here because, again, we do not know sigma and our n is small. Okay, we click on Summarize Data. Our sample size here is 25. Our mean was 13.2. And our S, our sample standard deviation, was 2.6. We want to make sure that in the options that our confidence level is what we want it to be. Yes, we did want 95% confidence. And also, whenever you're doing interval, you need to make sure the alternative says not equal. Press OK, and OK. Here you can find the 95% confidence interval, just the same as I calculated it by hand. Let's go to part B. Oh, I guess we also have to answer if there were any assumptions required. Okay, so here we are kind of making an assumption here. Okay, notice especially when I drew the picture, I drew it as a bell shape. Okay, the worry is that it's not perfectly symmetric. Okay, when the central limit theorem kicks in, when n is large, we know that it will be bell-shaped. So here we are assuming that this data is symmetric, okay, or roughly normal. I guess the other assumption that we might be making here is that this is only a valid sample if, of course, we've got random selection. Okay, so there's the assumptions that we're making. For part B, same information, but this time we'll change the sample size to be 45. Okay, so here, now we remember here that we still have S. S was 2.6, and we still have X bar, which was 13.2. Because we have S, we should really be using a t distribution. However, here n is starting to become large, meaning the central limit theorem will make this t distribution into a normal distribution. So we can actually use a z or a t. Okay, I just showed you how to use the t, so you can do that if you like. Well, but in this particular case, I will use the z distribution to do this confidence interval. Okay, I'll start by drawing the shape. I want to be 95% confident, meaning that the middle 95% is where I want to have my values. Again, I have 5% left over to share in both of these tails. 5% divided by 2 is 2.5%. Okay, and here I'm looking for these z values. Okay, I can find these z values, of course, by going to my z table and looking up the value 0.025. You'll find it in the negative 1.9 and 0.06. Okay, so I have my z alpha over 2 values. All that's left for me to do is use the formula for the confidence interval. This is x bar plus or minus z alpha over 2 sigma divided by root n. Of course, here I don't have sigma, so instead I will replace it with s. This will be x bar plus or minus z alpha over 2 s divided by root n. Okay, so this is 13.2 plus or minus my z alpha over 2 value, which I found here to be 1.96, times by s, which was 2.6, and divided by, sorry, that's actually 45, root 45. Okay, so let's see how we could, of course, calculate this by hand. Let's see how Minitab calculates this. In this case, we're going to stat, basic statistics, and a one sample z. We're using the normal distribution because n is large. Even though we do not know sigma, we know that the central limit theorem will make this situation into normal distribution. Okay, the sample size has changed here to be 45. Our average was 13.2, and our standard deviation was 2.6. Okay, make sure that the options, you have your confidence level set correctly. Here we want 95% confidence, and of course, because we're doing an interval, we want the alternative to be not equal. Press OK and OK to find the values here of 14.44 and 13.96. That's 12.44 and 13.96. Okay, finally, you should always remember what the interpretation of a confidence interval is. We can say, based on this sample, we are, of course, in this case, 95% confident that mu is between our two values, which are 12.44 and 13.96.